assume that they did get them all three. Okay. B will reply back with a sequence number on there of 4. Because what it will reply back with is one bigger than the last sequential one it got. And I'll show that in more detail you in just a second when we get to the next pieces. But it received 1, 2, and 3, so it replies back with 4. What that's telling A is start with number 4. So now A will send 4, 5, and 6. And let's say 4 and 6 are only received. 5 got lost somewhere. Now, under normal windowing, and this is an acknowledgement when it does this, is the type segment it sends. Under normal and traditional approach, what B will reply back with is 5 as an acknowledgement. And it will send that back to A. A now has gotten this. And we're assuming that this is something that goes from 1 to 50 maybe of segments in it. Okay. That's a weird looking E. But y'all know that's what that was supposed to be. All right. So now what A will send this time is 5, 6, and 7. Because what B did when it got 4 and 6 and 5 wasn't there, it really ignored 6 because it's not in sequence. And so it just trashes it. So 5, 6, and 7 will be sent to B. And now if B gets 5, 6, and 7, it will respond back with 8 because that's the next one it's ready to receive. All right. Do y'all follow how that one works? And this is traditional windowing right here. And if nothing shows up, if A sent, all right, so let's send the next one, 8, 9, and 10. And A sends that, and nothing gets to the other end. So the time that it should arrive in, they don't all arrive there. So essentially, nothing has arrived. But B knows it was looking for something, and it didn't get it in that time period. So guess what? B sends the 8 again, and then it gets resent. Okay. Questions on how that's working with using acknowledgements to send the information? And Ethan's looking around on the screen, looking at it with moving his mouse pointer around as he looks at it. Y'all got any questions about that process there? Because again, this will appear on certification tests. If you went and took Network Plus, you would see windowing on it. This is an important concept. And I don't know why. And I'm making a note in the book because I'm going to send her a set of notes about it. Because you're more likely to actually see windowing than you're to see three-way handshake, but you're very likely to see both of them. All right. That's the way it will work with acknowledgments and the traditional way of doing windowing. Things have changed in the last few years, but this isn't used extensively yet, and I really have not seen it on a cert test yet. But like Cisco includes it in their materials of teaching CCNA. And so I think you ought to be aware there is another approach works on this windowing. So I am going to take my eraser, which I've got to find again here. There it is. And I'm going to erase from here on down. Because what I want to show you now is that was with just regular acknowledgments. There is also where there's a selective acknowledgement, and that's new. It's only been around a short while. It's not used a lot yet, but it is being introduced in different places. So I want to show you that one and tell you how that one works a little differently. Because with the selective acknowledgement, you end up not resending things that were received. So in the case of this one, 4, 5, and 6, 4 and 6 were received. And I really ought to erase that too. So 6 was received of 4. It keeps it now with selective acknowledgement, because what it will send back in a selective acknowledgement and that's an SACK segment, it will send back what the numbers are it needs it to start with. So it will send back several numbers. So in this case, it would send back 5 and 7 to A. So that's telling it start with 5 and also start with 7. And by it being multiple on that, it knows, okay, that I need 5 sent again, and then start with 7 from beyond that. So in that case, what it would respond back with is not a sequential 3 of them, but it would respond back with 5, 7, and 8. It still sends only 3 of them and sends those 3. And that's the difference on the selective acknowledgement with the regular acknowledgement. The first one is what you're most likely to see with the acknowledgments. The second one is a newer, and you might see it, but it's a newer approach used in windowing. Does anybody have any questions for me about windowing at this point? Now, the other part of windowing is they did establish a window size at the beginning. And as the information's being sent, if lots of segments get dropped, don't get to B, either one of the machines can go, whoa, let's stop, and they'll proceed to do again their negotiation on the window size and go, okay, we're losing a bunch of segments, so let's cut the window size down. And so they'll reach an agreement on new window size, and then they'll continue sending on using that window size instead of the one that was originally set. Likewise, if they send a certain amount of the stuff and everything gets there, they will again look and see, can both machines work with a bigger window size? And if they can, they'll proceed to adjust the window size to that newer size, so that they can be the most efficient on transferring the data. And that can, depending on the size of the data that's being sent, how many segments is involved in it, that could be the negotiation could occur numerous times. Now, keep in mind, this is all stuff happening behind the scenes, not anybody's a user is not going to be doing it. And this is actually happening automatically. So you as an administrator aren't going to be setting the window sizes or anything either. But if stuff starts not working well, that is something you do want to look at and see whether you need to tell the machines that they need to operate off a different window size. So you can change the default values on that. So it could be a diagnostic part on it. So questions about TCP and UDP. UDP is the easy one because UDP, you just got to know it's connectionless. And with that, it's just sending it and assume it gets there. Much like radio and TV. TCP is connection oriented, and that is the term for it. And when it sends it, it makes sure it did arrive before it sends any more of the whole thing. So there is when it uses TCP, A knows B got the data. And the real life example to use as a similarity one to be able to remember it with is thinking about the telephone. Okay. In addition, with TCP, its segment is rather large and that it has a lot of stuff in it, which she goes through and illustrates on there. Biggest thing on it is that it does have a type of segment. UDP doesn't have that. It just has one type of segment, just ships it. TCP has about 6 or 7 different ones. We just talked about a couple of them that we mentioned that there's acknowledgement ones, there's request to send ones, which are synchronous ones actually, which is the SYN. There's acknowledgement ones. We said about there's termination ones. So there's a number of them available out there, but be aware of the synchronization, the acknowledgement, and the termination segments. Probably for your test, you're not really going to have to worry about it because it's not in the material. But if any of you decide to go on and take a networking certification test, you would run into it. I know on the Certiport one, I'm pretty sure that I remember there was a Windows question on there along with a 3-way handshake. I know on Network Plus, both of those things are on there, at least up through the current version of Network Plus, the one that's coming out now. I assume it's the same, but I have not looked at the competencies on it, and I have not been through training for it yet. So, but those are important ones. TCP and UDP are the two main protocols on the transport layer. Okay. So that gets us through that part. So next thing they talk about a little right here, she talks about is she goes into a little about internet protocol or IP. And actually, we talked a little bit about that in the previous chapter of IP version 4 and IP version 6. She goes into actually the segments, she's calling them packets, and they are packets because IP would be packets because IP is down there on the network layer of the OSI model or the internet layer of the TCP IP model. So with IP, the packets that she shows you what an IP version 6 packet looks like and the header that's on it. And remember, the packet is encapsulating the segment in it. Okay. And then the she also shows you the IP version 6 packet also which is similar to the IP version 4.1, except it's larger because, after all, it does have addresses in there. The IP version 4 has 32-bit addresses. IP version 6 has 128-bit IP addresses in it. So obviously, and then it changes a little bit on what it calls a few things. One of the things that goes on that packet, which also was back there on the segment, which I didn't mention, but say the two big things on the segment was the actual chunk of data and the segment number. There's also in there on the segment a length of the data in the segment and such. The packet has the same stuff in it that is going to have on there the length and some other stuff. Another one though for you to that you may find interesting. Well, one thing is it does have on there what version of IP it is, and then that's going to dictate how all the rest of the stuff is set up. That on IP version 4, it's got something on there called time to live, or TTL. What time to live is that every time it hits a router, and when the router gets it, the router's going to undo the packet and look at it to see what all is in there. It's got a also a field in there that's a checksum field, which calculates a number on the header, and so you make sure it all arrives there. But the time to live, each time it goes through a router, and when it goes through the router, that is actually going to be changing IP addresses because it's going to change where it was sent from to that router and which router is it sending to next, unless it's going to the actual last location, which it will use MAC addresses to determine that one. Wait a minute, I just told you wrong on that. The IP will stay constant of where it was originally sent from, and the IP address will tell it where it ultimately goes to. But the time to live says as it goes through routers, it will count down the time to live. So when it initially sends it, it will put a time to live on there of the maximum number of routers or hops that it should do. And all a hop is a connection from router to router, and it's pictured like this. So if this is a router, and this is a router, as it that's a circle, believe it or not, and then a plus sign inside of it. As it travels, it's going to go from router to router to router. Okay? And notice how that's illustrated when they illustrate it. They're called hops, just like our rabbit hops. And so that's how many. So when it left here, it had a number 17 on it. When it leaves this one, it will have a number 16 on it. When it leaves this one, the time to live will then be on it a 15. And it counts on down till it hits 0, and then it just stops. And that can be set by the administrator on what the time to live is going to be. But that's to keep packets from just floating out on the internet forever trying to find where they're going. If it can't find the destination after so long, it will eliminate it through the time to live. On IP version 6, that it has on it, she called it a hop limit. Trying to think. Hop limit doesn't sound right, but it's not. It is different than time to live. but it's really the same thing and it calls it differently. So hop limit could be correct. So we'll go with hop limit, but it's going to call it hop limit instead of time to live, because time to live sounds like a certain amount of time when it's actually a number of hops. So when they did 6, they changed it and went to hop limit of that it's so many hops out there, and that could be a variable amount of time to get from this router to this router could take a lot longer than it takes to get from this one to this one. There's not consistent time lengths because these could be substantially located apart distance wise. Second one is what type connection do they have between the two routers? Do they have a fiber optic connection? Do they have a copper connection? So that will be significant on that. So I'm going to close my whiteboard here and go back to here.